Final video in this series of demo videos on the Pi EVM. And this is just one I'm going to run through a couple times, increasing the difficulty to show you the difference of the logs. With this, if you follow the write-up, everything has been uncommented from the code provided, and everything should be working at this point. And after you feel confident with how we were able to print values out and how to access certain things in cast to print out the actual values of things, you can go out, and if you want to test something or see something else, just follow the pattern of know what you're doing in Python and know what you can print out and what you can access, and it's an awesome sandbox. Honestly, it's one of the quickest and easiest ways I've actually understood like a transaction and everything like that on like a crypto level. So come down here to our good old trusty main.py. Everything has been uncommented. We have gone through all of these before in the previous videos, but all in the validation, the base, the transactions, proof of work, ABC, and chain.py. Everything that I have noted and changed, in which you can see in the write-up, has been documented, and this is the end result. So we have everything. We're going to run the Python file with a difficulty of 1. Wrong. There we go. Virtual environment. So there we go. So like we saw in the previous video, we have all these logs, and it is to a point where it's probably best that you only want to comment out the logs that you are currently running, but this is all what it does. And if we go back to the text editor to show the difficulty increasing the amount of execution time. I was trying to get a timer so I can do hash rate and things like that to calculate how quickly your Python EVM was running, but I know in Geth they have something like that. I wasn't able to get it to work in here nicely, unfortunately. I'm sure it's some more work that I'd be able to do it, but as we saw in the first one, we now have 2 when we increase the difficulty to 10. Everything else is the same, so we're going to come back here, increase difficulty to 100, so we should have more in those logs. And these are getting run real time, so we'll clear. So we actually see proof of work real time. So when it starts scrolling like that, that was proof of work real time. That's how quickly you're doing your guesses. And you can see your guesses right there as well. And we see our winning guess right here and everything like this, which is nice. And we can go back, make it 999, so the max that we can have without going over a guess limit. And actually we'll do one when we actually go over the guess limit, so we'll clear. And when we do go over the guess limit, that's not my code, that's what's built into the Pi EVM. So this is with 999, so it's gonna take a little while. Finds it, awesome. We can scroll through all the things like that, and oh yeah, when we change everything like that, we can see difficulty changes in the block. So it's one of those things where you can just run it and quickly see all your values and see where they're going, how they're getting transformed, and everything else like that. But let's see if we go out of bounds. So let's add a 0 to that. So save and run. Clear first. It must be 10,000. Oh no, there we go. Giving up too many attempts. So it was 999. Cool. Well, that's just something cool that you can see when, like, if you're testing things in your setup, like in this Genesis block, right here. So this is out of bounds, but when we go and look at this, we have, oh, in this method, in this path, we see what breaks. So we go to here, and if we go to proof of work right here, we can see that max test mod attempts is 1,000. So let's increase it to 100,000. Save. And so that was an actual change of source code right there. This is source code. That's the built-in default. So we just changed the actual source code of how this operates. Let's see if it works. It could just completely break something else, but this is the first time I'm doing it. We're gonna see what happens. As we can see, the PW notch result cap stays the same. That's the thing we're checking against. And we're gonna let this run to see what happens. And this is more realistic to what the real world is like, where it's just brute forcing this with as many guesses as it can. Since I've never run this before, I have no idea how long this will run. So we'll give it 2 or 3 more minutes, and if it hasn't stopped, I'll keyboard interrupt it because it's a Python code, so Control D, Control C, exit, something like that, and it'll stop execution. Which, again, just goes to how awesome this sandbox environment is. It's just something that I stumbled across last minute in my blockchain education and research myself, and this by far has been the best hands-on. Oh, there we go. We found the value. This PyEVM is a fantastic like beginners level because it is Python. So if you do have Python experience, you'll get this way easier than Geth, which is going to be your JavaScript implementation of this. And this one you can run a single file, or you can run it as an interactive console. The interactive console, you can do all the commands. It's just if you want to run a lot of things like we do in our main file, it's just way quicker to run the file itself. But yeah, that's just an example of changing source code, putting in print statements, and debugging the actual source code to figure out what's going on underneath the skin. So I really enjoyed this journey of education. It's been invaluable, and it's just really awesome to say that you know blockchain from the high level down to, oh yeah, I know how they get the parent hash of the previous block through the KECCAK 256 algorithm and things like that. But I had a lot of fun on this project. It's been a fun ride, and I hope to continue my education on it, and it's been a lot of fun. Thank you all for watching all these videos. If you have any questions, please write down in the comments, and I'll get back to you as quickly as I can. Thank you so much. Bye.